Hello and welcome to the Z Hut. Today we will take a look at how to assemble, wire up, and program the Z3D NRF24L01 Arduino joystick. Before we put it together, let's take a look at the specs. The Z3D RC joystick features two joystick modules with X and Y access and one push button on each stick, providing up to 4 accesses of control and 2 push buttons. These are the black Chinese joystick modules. Do not use the red Adafruit joystick modules, they will not fit. The Z3D RC joystick uses the high-powered NRF24L01 transceiver, allowing for a range of up to 1 kilometer. The brains of the whole joystick is an Arduino Pro Mini, the ATmega 328P 5V 16 MHz version. To power everything is a single 9-volt battery that attaches to the bottom with a rubber band. To power the joystick on and off, just simply connect or disconnect the battery. The joystick frame is 3D printed. If you don't have a 3D printer, don't worry, you can buy the frame already printed. But if you have a 3D printer, you can download the files and print it yourself. The files and a link to where to purchase a printed model can be found on this project's website. There is a link in the description below. All of the parts for this can easily be found on eBay or Amazon. A full parts list with links is available on the website. Let's get started putting the Z3D joystick together. First, use an M2x12 bolt to seat all the nuts. 2 for each joystick module and 1 for the NRF24L01 lockdown. You can use 4 nuts and bolts for each joystick module, but 2 is plenty to secure them. Next, attach both of the joystick modules using M2x8 bolts and washers. Make sure the header pins are facing forward. Next, plug the NRF24L01 into the breakout board and then insert it into the frame. Once inserted, use an M2x8 bolt and washer with the lockdown and secure the NRF24L01 module. Next, check to see if your mini breadboard fits. Some, depending on the manufacturer, may need very minor filing if they are too big. When you have confirmed it fits, peel off the backing to expose the tape and then secure it to the frame. Alright, let's move on to placing the components on the breadboard and then wire it all up. I recommend you place all the components on the breadboard the same exact way I do. This board is small and limited in space for the connections. First, place the Pro Mini on the breadboard to the far right, with 3 open rows above it and 2 below. Next, bend the tabs on the voltage regulator in the middle back to a 90-degree angle. Then, insert it into the breadboard in the upper left-hand corner. Then, place your diode so the anode is connected to the VCC pin on the Arduino and the cathode is connected to the first open row of connections next to the Arduino board. The voltage regulator and diode are necessary for the NRF24L01 to function properly and reliably. It may work without these components, but it will have problems and not work reliably. Now we still have 2 capacitors to place on the board, but we will wait until later so they do not block our view of the breadboard. Next, we need to add a few jumper wires on the breadboard. 1 between the Arduino's VCC pin and the right side tab on the voltage regulator. Then 3 jumpers on the left side of the breadboard, bridging the rows of connections across the breadboard. Finally, place a jumper between the ground pin of the Arduino board and the middle pin of the voltage regulator, like this. Now we can move on to connecting the joysticks to the Arduino board. For this, we will be using 10 centimeter male to female jumper wires. Let's start with the stick on the right. First, connect the ground. Connect 5-volt pin of the joystick to the VCC pin on the Arduino. VRX to A0, VRY to A1, and SW to digital pin 5 on the Arduino board. Moving on to the left joystick module, connect the ground pin to ground. The 5-volt pin to the 5-volt output of the voltage regulator. VRX to A2, VRY to A3, and finally SW to digital pin 4 of the Arduino board. Now let's connect the Arduino board to our NRF24L01 module via the breakout board for it. Connect VCC to the cathode of the diode. Ground goes to ground. MI goes to digital pin 12 on the Arduino board. MO connects to digital pin 11. SCK connects to digital pin 13. CSN connects to digital pin 9. CE connects to digital pin 8. And finally, the IRQ pin is not used. Next, we can add our two capacitors. Make sure the negative tab of both capacitors is connected to the center tab of the voltage regulator. The software I used to make this schematic would not allow me to rotate the second capacitor, so its tab is incorrect in the schematic and should be flipped. Next, connect the leads from your battery connector to the input of the voltage regulator and ground. Now that we have everything wired, the last step is to use a rubber band to connect the 9-volt battery to the joystick, like this. Okay, let's take a look at the sketch. The first thing we need to do is get the library for the NRF24L01. In the Arduino IDE, click on the Sketch tab. Under the Include Libraries tab, select Manage Libraries. In the Library Manager search box, type in NRF24L01. Then scroll down until you find the RF24 library by TMRH20 and install it. Now that you have the library, go to this project's website and copy the transmitter sketch and paste it into your Arduino's IDE. The only part of this sketch you may need to change is the radio's channel, but I will go through the sketch and explain what everything does. To start with, we are including the two libraries we need for the NRF24L01, the SPI and the RF24. Next, we are setting what pins on your Arduino board we used for the CE and CSN pins on the NRF24L01. This line is setting the address for the NRF24L01. You can change this, but if you're not using multiple NRF24L01 modules, there really is no point. Next, we are setting up an integer array that we will use to store all the readings we take from the joystick modules. It's named Joy, short for joystick, and set to store 6 values. In the void setup, we are starting off by starting up the NRF24L01 radio and then setting it to the writing address of 00001 that we defined above. This line of code sets the radio's data rate. For remote control, you will want to leave this at 2 megabits per second. You can get longer range with a slower rate, but it's not as reliable and the controls will be sluggish. This sets the radio's power level. Unless you are using this at close range or you need to minimize interference it may cause, leave it set to high. Changing it to low will significantly decrease its range. Next, we are setting the radio's channel. The RF24 library has an example sketch included called Scanner. You can use this to scan all the radio channels and find one that is not being used and then enter its hex value here. In the description below, there will be a link to a video for tips and tricks for the NRF24L01 that will cover how to find a good channel to use by using the scanner sketch. Next, we are activating the pull-up resistors for the Joysticks push buttons. For testing your joystick while it is connected to your computer, you can use the serial monitor. Uncomment this line of code to start the serial communication. I will cover more on this in just a few moments. Moving on to the void loop, we are starting off by setting the radio to transmit mode by telling it to stop listening. Next, we are taking readings from both joystick modules X and Y and push buttons and saving them to the Joy array. Then we have some more code for testing. Uncomment this and you can check if all of your connections to the joysticks are correct and working using the serial monitor. Next, we are taking our readings and mapping them so the values are between 0 and 255, which is what the Arduino uses for PWM control. If you are going to use this joystick to control servos, change the mapping from 0 to 255 to 0 to 180. Next, we have some more code for testing. This time, if you uncomment it, it will show you the joystick's mapped values on your serial monitor. Now we have the line of code that sends the whole array to the radio to transmit it. And finally, we have a short delay to keep from overloading the receiver with data. Alright, let's try the joystick out. If you want to try this, you can find the wiring schematic and Arduino code for the receiver on the website. Thank you for joining us here today at the Z Hut. Please remember to like, share, and subscribe.